China's Liaoning province is a land of hidden treasures, a place where the past comes alive through the ground beneath our feet. Not gold or jewels, but something much older and more amazing: fossils. These ancient remnants tell stories of life that existed millions of years ago. This region is famous among paleontologists, scientists who study ancient life. They come from all over the world to uncover these hidden stories. Why Liaoning? Because the rocks there hold secrets from a time long ago, the time of dinosaurs. These rocks are like pages in a history book, each layer telling a different chapter. For millions of years, fine layers of volcanic ash settled onto the ground in Liaoning. These layers acted like a time capsule, preserving the remains of ancient life. These layers preserved the remains of plants and animals in incredible detail, capturing even the most delicate features. It's like a snapshot of life from 125 million years ago. Imagine being able to see what life was like back then. This period was the Early Cretaceous, a time when dinosaurs were thriving. The landscape was lush and teeming with life. Among the most exciting discoveries in Liaoning are feathered dinosaurs. These fossils provide a unique glimpse into the evolution of these magnificent creatures. These fossils have revolutionized our understanding of dinosaur evolution, showing us that many dinosaurs had feathers, much like modern birds. Recently, another astonishing find emerged from the rocks. Each new discovery adds a piece to the puzzle of our planet's history. A new species of theropod dinosaur, a relative of birds, was unearthed. And it wasn't alone. This discovery has opened new doors to understanding the link between dinosaurs and birds. Tiny creatures were preserved alongside it, revealing a fascinating story about life and death in the dinosaur era. Let's uncover their secrets and learn more about this ancient world. Imagine a small but fierce predator about the size of a chicken, darting through the undergrowth. This is the world of our new dinosaur. It's a theropod, meaning it walked on two legs and had sharp teeth and claws. This dinosaur wasn't big and powerful like Tyrannosaurus rex, but it played an important role in its ecosystem. Its discovery adds a new piece to the puzzle of dinosaur diversity. Every new fossil helps us understand how dinosaurs evolved and interacted with their environment. This new dinosaur was covered in feathers. These weren't feathers like you see on birds today, used for flight. They were simpler, more like downy fluff. These feathers likely provided insulation, helping the dinosaur regulate its body temperature. But the feathers held another secret, one that gives us a glimpse into the daily lives of dinosaurs. Tiny, dark shapes were preserved among the feathers. What were they? Parasites? Feathers are more than just for flying. They are a marvel of nature, serving multiple purposes that are crucial for a bird's survival. They provide insulation, keeping birds warm in cold climates, and camouflage, helping them blend into their surroundings to avoid predators. Additionally, feathers play a vital role in mating rituals, with many birds displaying their vibrant plumage to attract mates. Finding feathers on a dinosaur tells us a lot about its lifestyle. It suggests that these ancient creatures might have used feathers in similar ways to modern birds. In the Liaoning fossils, the feathers are so well preserved that scientists can study their structure in detail. This exceptional preservation allows researchers to understand the intricate details of feather anatomy. They can see the individual barbs and filaments that make up the feather, providing insights into the feather's function and evolution. This level of detail is incredibly rare and provides valuable information about the evolution of feathers. It helps scientists piece together the history of how feathers developed over millions of years. The feathers on this new dinosaur are similar to those found on other small theropods in Liaoning. This similarity indicates a common evolutionary trait among these species. This suggests that feathers were widespread among this group of dinosaurs, highlighting their importance in the lives of these ancient creatures. It supports the idea that feathers evolved for insulation and display before they were co-opted for flight. This evolutionary path shows how feathers adapted to different needs over time. The presence of feathers also tells us something about the dinosaur's environment. It provides clues about the climate and conditions these creatures lived in. Liaoning during the Early Cretaceous was warm and humid, but the presence of feathers suggests that the nights or winters may have been cooler. This duality in climate conditions would have made feathers an essential adaptation. Feathers would have helped the dinosaur stay warm during these colder periods, ensuring their survival in a changing environment. This adaptability showcases the incredible versatility of feathers throughout history. The parasites found on the dinosaurs' feathers weren't just any parasites, they were ancient fleas. These tiny creatures have been around for millions of years, surviving through various epochs and adapting to different hosts. These tiny insects are related to the fleas we know today, but they had some key differences. Unlike the fleas that bother our pets, these ancient fleas had unique adaptations that made them well suited for their prehistoric hosts. For one, they were much larger than modern fleas. Imagine a flea the size of a small coin, much bigger than the tiny pests we see today. They also had longer legs and a more robust body. These physical traits likely helped them cling to the feathers and skin of their dinosaur hosts more effectively. These ancient fleas likely fed on the dinosaurs' blood, just like modern fleas do. Their feeding habits would have been similar, piercing the skin to suck blood and survive. The fact that they were preserved on the feathers suggests that they were living on the dinosaur's body, not just feeding on it occasionally. This indicates a close and possibly long-term relationship between the fleas and their hosts. This discovery is exciting for several reasons. It opens up new avenues for understanding the interactions between ancient parasites and their hosts. First, it provides the oldest known evidence of fleas. This pushes back our understanding of when these parasites first appeared on Earth. These fossils push back the evolutionary history of fleas by millions of years. It shows that fleas have been a persistent part of the ecosystem for a very long time. Second, it shows that fleas were already specialized for living on feathered animals during the time of the dinosaurs. This specialization indicates a long evolutionary history of adaptation to their hosts. The presence of fleas also tells us something about the dinosaurs' hygiene. It suggests that, like modern birds, these ancient creatures had to deal with parasites regularly. Just like modern birds, feathered dinosaurs likely spent time grooming themselves to remove parasites. This behavior would have been crucial for maintaining their health and preventing infestations. This behavior would have been important for their health and well-being. Grooming not only helped them stay clean but also played a role in social interactions and bonding within their groups. Section 5. Understanding ancient fleas. These weren't your average everyday fleas. Oh no, these were prehistoric bloodsuckers. Their size alone sets them apart. Imagine a flea, but instead of being tiny, it's as big as a grain of rice. That gives you an idea of what these ancient critters were like. But it's not just their size that's intriguing. The shape of their legs and bodies tell us how they lived. Those long legs, perfect for clinging onto feathers and moving quickly through the jungle of a dinosaur's plumage. And their sturdier bodies? Well, they probably needed a bit more muscle to pierce the thicker skin of a dinosaur compared to a bird. Finding these fleas alongside the dinosaur isn't just a creepy crawly bonus, it's a major clue. It tells us that these parasites were already adapted to living on feathered creatures way back then. They were part of the ecosystem, just as fleas are today. Section 6. Feathered friends then and now. Birds are the only dinosaurs alive today. They are descended from feathered dinosaurs like the one found in Liaoning. Studying these ancient fossils helps us understand the evolutionary link between dinosaurs and birds. Just like birds today, feathered dinosaurs had a variety of feather types. Some feathers were for insulation, others for display, and eventually, some evolved for flight. The feathers of the Liaoning dinosaur provide a glimpse into this evolutionary process. The parasites found on the dinosaur also have modern counterparts. Birds today are still plagued by lice and mites, just like their dinosaur ancestors. This shows the long and enduring relationship between parasites and their hosts. By studying these ancient relationships, scientists can gain insights into the evolution of both parasites and their hosts. They can learn how parasites have adapted to different hosts and how hosts have evolved defenses against parasites. Section 7. More than just a meal. Those ancient fleas weren't just after a quick snack. They were deeply intertwined with the lives of feathered dinosaurs. Think about it. Where do fleas lay their eggs? Often on their host or in their nests. So these fleas were probably constant companions of our little dinosaur. This means the fleas were affected by everything in the dinosaur's life. The dinosaur's diet, its environment, even its social interactions. If the dinosaur traveled, the fleas went along for the ride. And just like fleas today, they probably jumped from one dinosaur to another, spreading perhaps not just between individuals, but maybe even between species. This tiny detail about fleas paints a bigger picture. It shows us that even back then, ecosystems were complex. Animals weren't just living alongside each other, they were connected in intricate webs of relationships, from predator-prey to parasite-host. Section 8. The Liaoning puzzle pieces. Every fossil found in Liaoning is like a puzzle piece. Each piece, on its own, is interesting. But put them all together, and you start to see the bigger picture of life in the early Cretaceous. We have the feathered dinosaurs showing us the evolution of feathers and the link to birds. We have the ancient plants telling us about the climate and the environment. And now, we have these fleas, revealing the complex relationships between species. The Liaoning fossils provide a window into a time when dinosaurs were at their most diverse. They show us the incredible variety of life that existed during this time, from giant sauropods to tiny insects. And the discoveries continue. Every year, new fossils are unearthed in Liaoning, adding to our understanding of this fascinating period in Earth's history. Section 9. Looking through the window to the past. The discovery of this new theropod dinosaur and its fleas is a reminder that there is still so much we don't know about the past. It's a call for continued exploration and discovery. By studying fossils like these, we can learn not only about the past but also about the present and the future. We can gain a deeper appreciation for the diversity of life on Earth and the interconnectedness of all living things. The Liaoning fossils are a gift from the past. They are a reminder of the vastness of geologic time and the incredible journey of life on Earth, and they are an inspiration to continue exploring, discovering, and learning about our planet's ancient past.